Right, I'm trying another recording here. What are we doing? We're doing 2018. Maths 4 2018. Question 3. A. Integration. This is using the root mean square formula. So there's the question. And the root mean square formula looks something like this. The image here is here. Right, this comes in the back of the exam paper. So let's squash it down a bit there. Stick it up here. Right. Now, we have v here, but yv doesn't really matter, so y equals 25 sine 50 pi t, right? We want y squared now. We're getting ready to use this formula. We're going to get y squared. Y squared, because we want this bit in here for integration, right? Y squared will equal 25 squared, which is 625. So I have 625 sine 50 pi t. This whole thing is going to be squared, so you could have the squared out there, but they write it like this. You know, you put the 2 up there. 625. Hold on now till I pause this, yuck. Oh, where were we? Right, 625, right? So that's y squared. So now, this thing is very awkward to integrate, so we have another wee trick to sort that out, right? And also from the back of the exam paper, yeah, a thing like this sine square substitution rule thing, right? Here it is here. So we'll bang that up there. Now, you see this sine squared x? When we see, with us, we can say that x is equal to 50 pi t. So sine squared 50 pi t. Now we'll keep our 625. So sine squared 50 pi t will become, this will be multiplied by, right, 1/2 times 1 minus cos 2x, which will be 2 times this guy here, which will be 100 pi t. And we can tidy things up. 625 divided by 2 equal, 625 divided by 2 equals 312.5 times 1 minus cos 100 pi t. Right, so this is y squared, and we're going to get the average value of y squared using this integral structure over here. B for us will be 20, B will be 20, and A will be 0. So, to get the average value, we're going to integrate 1 minus B, take away A, times the integral between 0 and 20, 312.5 times 1 minus cos 100 pi t. Now, we can take the 312 outside, and that will become 312.5 over 20 times our integral, 0, 1 minus cos 100 pi t dt should be really, right? So, now things are much more integratable. We'll tidy up that outside bit, and we end up with 15.625 outside. Just make some space here. So we've 15.625, right? And we're ready to integrate now. So 1 integrates to t, minus cos integrates to sine. So you're going to have sine 100 pi t over the first derivative of the structure in here, over the first derivative of this bit. So that goes to 100 pi. And we've yet to apply our limits, so I'll write them out here. Okay, so now we're going to apply our limits. 15.625, open a bracket, we'll have a bracket here, minus another bracket here, and we'll use 20 in the first one, so that'll be 20 minus sine 20 times 100 pi comes to 2000 pi over 100 pi. In the second bracket, t becomes 0, so minus, or 0 minus sine of 0 over 100 pi. Now the sine of 0 is 0, so the second bracket doesn't really count. And also the sine of 2000 pi, make sure your calculator is in radians, equals 0. So we end up with, so that goes to 0. So we're going to have 15 times 20. Right? 15.625 multiplied by 20 gives us 312.5. So we have 312.5. What's that? That's y bar squared. Right? Now if we look back up, we're looking for the root mean square, so that's going to be the square root of this here, y bar squared, right? The square root of it. So the root mean square equals the square root of y bar squared, the square root of 312.5, and I'm going to go square root last answer, square root last answer, and SD that I get 17.6. 17.677. The question asked if the four significant figures 1, 2, 3, 4, 5. So that last 7 there causes the fourth digit there to go up to 8, and the answer is going to be in volts. That is it, I am reasonably sure.